Dear students, as you know, we are still cultivating the concept of equivalent weight from the oxidation number. Let's roll further and how do we solve simply by taking this equivalent weight concept, a stoichiometry problem, a difficult stoichiometry problem associated with one or more than one reactions that you can easily solve by taking this concept. See, you know, before going to stoichiometry solve by taking equivalent concept, I am discussing some compound which will act as oxidizing or reducing agent in our common stoichiometry reaction. Like H2O2, H2O2, here the oxidation state of oxygen is -1. It can oxidizes to oxygen or it can reduces to H2O or OH minus. Remember this H2O2. It will be oxidizing earlier by reducing it. When it will oxidize to O2 0, here N factor 2. Here N factor is 2. Say -1 to 0. That is 1 more electron loss. Since there are 2 oxygen, that's why N factor here is 2. And equivalent weight is equal to molecular weight by 2. That means when H2O2 will act as reducing agent itself oxidizes to O2, there N factor 2 and equivalent weight equals to molecular weight by 2. That is, molecular weight of H2O2 34. If you take 34 gram H2O2 associated with 2 mole electron transfer, if I take 17 gram of H2O2 associated with 1 mole electron transfer, that 17 gram is the 1 gram equivalent of H2O2. Similarly, when it will reduces to H2O, that is -2 oxidation number. Here also -1 to -2 for 1 oxygen. For 2 oxygen is 2 mole electron transfer. Here also N factor is 2 and equivalent weight is equal to molecular weight by. That means H2O2 for both case, oxidant as well as reductant, N factor 2 remember. 1 gram equivalent of H2O2 equals to 17 gram of H2O2. Now, see another example. There we get sodium thiosulfate, Na2S2O3, sodium thiosulfate. This is called hypo solution, standard sodium thiosulfate solution, primary standard. When it will react with I2, it will form Na2S4O6 plus NaI. See the reaction, the complete reaction I have taken here. And the reaction associated with iodometric titration. By using this reaction, you can estimate iodine. You can estimate unknown amount of iodine from known amount of sodium thiosulfate. Here see the average oxidation number of sulfur +2, here +2.5. That means here equivalent weight 0.5 increase per sulfur atom. Since there are 2 number of sulfur atoms, 2 into 0.5, 1 equivalent weight is equal to molecular weight. 1 mole electron plus. Iodine 0 to -1. 1 more electron transfer, but I2, 2 iodine atom, that's why E is equal to M by 2. And if you do balance, see, here the mole ratio 2:1 that you got from the balanced equation. But here E is equal to N, equivalent ratio, see, equivalent ratio. 2 mole means 2 gram equivalent, since E is equal to F, 2 equivalent, 2 gram equivalent. But here E is equal to M by 2. 1 mole equals to 2 gram equivalent. That means here equivalent ratio 1:1. That I told you, any reaction always occurs by 1:1 gram equivalent ratio. I discussed application of this iodometric reaction. This is an important titration and it has great importance. Why it is important? You can think that is by using this reaction only we can estimate IOD. Although it is specifically for the estimation of iodine, but it is highly important. Highly important are those things which are generalized and enormous application, broad application is present, then it is important. It has broad application. This reaction not only used to estimate I2. Remember, see my point. Some oxidizing agent I have taken use. Oxidizing, any oxidizing agent that I will discuss later. Like we oxidize I2. And the oxidizing agent reduces some reduced species. That may be anything. Now, there are so many oxidizing agents in our syllabus, which will able to oxidize iodide to IOD. I can say H2O2 in acid medium oxidizes iodide to IOD. H2O2 in acid medium oxidizes iodide to IOD. Ozone oxidizes iodide to IOD. Any transition medium which will show variable oxidation state. Their higher oxidation state alloy oxidizes I minus to I2. Itself reduces to their lower oxidation state. For example, cupric oxidizes iodide to iodine, itself reduces to Cu+. Ferric oxidizes iodide to iodine, itself reduces to ferrous. HNO3 oxidizes iodide to iodine, itself reduces to NO2 or NO. MnO4- in acid medium oxidizes iodide to iodine, itself reduces to Mn2+. One thing remember here, halogen stable only in acid media. That explanation is different part that I will explain later in different video. But remember, a halogen stable only in acid media. The diatomatic in acid media oxidizes iodide to iodine. There are so many reagents we have in our syllabus that will oxidizes iodide to iodine. Now, for example, you want to estimate the unknown amount of potassium dichromate. By using this reaction, how you will do this? I will take potassium dichromate in acid media. There I will add excess Ki. That way potassium dichromate should limiting there. It should participate all in the reaction. Then what will happen? That potassium dichromate, if I take this is potassium dichromate in acid media, K2Cr2O7, medium you had to take acylic. Since you know it will act as oxidizing agent in acid medium only. It will oxidize as iodide to iodine. It is limiting. Total iodide. Limiting here oxidizing agent. I have taken it is excess. It is excess. That means total dichromate in acid medium used in this redox reaction where total dichromate of this reaction oxidizes iodide to iodine, itself reduces to CSC+. Now this liberated iodine, the amount of iodine you got from this second redox reaction. And this oxidizing agent, maybe H2O2 in acid media, maybe permanganate in acid media, maybe copper sulfate, maybe ferric chloride, maybe HNO3. This liberated iodine you can estimate by using this standard hypo or sodium thiosulfate solution. If you know this amount, you will get the amount of iodine. Once you got the amount of iodine, you will get the amount of dichromate. That means by using this iodometric reaction, that is Na2S2O3 plus I2, Na2S4O6 plus NaI. By using this iodometric titration, you can estimate any oxidizing agent. You will get amount of oxidizing agent which are oxidizes iodide to iodine. That's why it has enormous or broad application. That's why it is important. And this is I can weigh the stoichiometric formula by taking this two reactions. For example, I have given sodium thiosulfate amount. I have not given H2 amount in acid medium. What I will do? In H2 in acid medium, I will put excess Ki. And the liberated iodine I will estimate by using the known amount of hyposolution or sodium thiosulfate solution. Now, the question may arise, sir, this is too much lengthy. But remember, it is not lengthy problem. See, if you take the concept of equivalent point, I told you, always there occurs any reaction by 1:1 gram equivalent ratio. Oxidant is to reductant, always 1:1 gram equivalent. That means 1 gram equivalent exactly reacts with 1 gram equivalent. So it's 1 electron transfer. Now, this is unknown, this is known. If this ratio is 1:1 gram equivalent, then it is 1 gram equivalent. And it is 1 gram equivalent, it is 1 gram equivalent. Focus on my point, the magic of this. This is given. The given may be in volume and molarity, and volume into molarity is the Bj mole, or directly it may be given in mole. If you are able to convert this mole into gram equivalent from the n factor 1, n factor 1 means mole equals to gram equivalent. That means you can easily convert this amount to gram equivalent unit. Remember, this gram equivalent equals to this unknown gram equivalent, although there occurs no reaction directly. Since if it is 1:1, then it must be 1:1. Then this and this amount of ratio always 1:1. Then if in any problem there are more than one reaction involved, or more than 2 reaction, 3 reaction involved, you can solve that problem by same time if it is with one reaction. Since the procedure is same, the given any stoichiometry problem is one component is given. The given amount, just you have to convert to gram equivalent unit with respect to that reaction, since you know n factor by here. Now, gram equivalent 1 is known, the unknown gram equivalent must be set. If time will permit, in another video I will discuss by taking different problem how you will solve a stoichiometry problem within 30 seconds by taking 1:1 gram equivalent ratio. That means this iodometric titration has great application in stoichiometry, since it will able to estimate so many oxidizing agent, unknown amount of so many oxidizing agent which will oxidizes iodide to iodine. Okay. There is a problem. Here 2 moles KMnO4 in acid media. See now how I will solve within 1 minute or 30 seconds. 2 moles of KMnO4 in acid media reacts with excess here. The question is, how many moles of bromide will be formed as product? How many moles of bromide will form as product? See the technique. How do I will solve it? And follow this technique, follow this method in different problem. You can solve very easy. Want here to know You know, permanganate in acid medium reduces to Mn2 plus. It is associated with 5 moles electron transfer that I discussed in the previous video oxide concept of equivalent weight. That you have to know. MnO4 minus, you know the medium is acidic. It will reduces to Mf2 plus. From the oxidation number, you know it is plus 7, it is plus 2. 5 electron accepted by permanganate. I have taken 2 moles of MnO4 minus in acid medium. The 2 moles of MnO4 minus, how many number of moles it will accept? 2 into 5, 10 moles. Moles of electron. Here electron like a currency. You have 10 moles of electron in your hand. Now, you will get electron by oxidation of bromide to bromine. And from there, you have to get 10 moles of electron. You know that when bromide oxidizes to bromine, 2 minus to 0, it will lose 2 moles of electron. That means when your product 1 mole bromine, it is associated with 2 mole electrons loss. But in your hand, there are 10 moles of electron. You can say simply 2 moles electron give 1 mole bromine. But you know, your hand is 10 moles of electron, that is defined given 2 moles of KMnO4. Then 10 moles electron will give 10 by 2 moles of bromine. 5 moles of bromine. Easy solved. What I have equated here, number of electrons, loss are there. I have converted number of volts to number of volts of electron transfers. And that electron transfer I have equated in the oxidation part. And your answer is 5 moles bromine. By this way, you can easily solve any stoichiometry problem within 30 seconds. Here I have discussed, for discussion I have taken time, I have split. But when you will do solve this, just one line to it take. 2 moles electron, 2 moles particle and 10 moles electron. 1 mole bromine from 2 moles electron, then 10 moles electron will give 5 moles bromine. You can easily solve it. I want to give another example. I am not going to concentration molarity numeric. Another example. There are 4 moles dichromate given in acid medium. Thiosulfate. I'm writing in ionic part only. Thiosulfate. Question is, how many moles of sulfate will form as product? How many moles of sulfate or sulfur containing product will form as product? See, how do I solve? You know this part here 207, 2 minus, medium acidic, it will reduces to shear 3 plus. Here 6 mole electron transfer, that you have idea, plus 6 to plus 3. 1 chromium 3, Since there are 2 bromine, 6. I have taken 4 moles. That means 4 moles dichromate associated with 4 into 6, 24 moles of electron. Now you know thiosulfate is a powerful oxidizing agent. Thiosulfate is 2O42 minus, S2O32 minus. I'm not doing balancing. Without balancing, it will oxidizes to its highest oxidation state, SO42 minus. And here you have to write 2. Here see plus 2, 2 plus 6. Tell me, 4 electron lost for each sulfur. Then here 2 sulfur. That's why 8 electrons. And the 8 electron give you, 8 electron loss give you 2 moles sulfate. And in your head there are 24 moles of electron. Then just cross multiplication, 24 moles of electron will give 2 by 8 into 24 moles of sulfate. That means 6 moles of sulfate. Easily by equating the number of moles of electron transfer. A complicated problem we can simplify. Loss of electron equals to the gain of electron. Since you know in a balanced equation, never you will get electron in the balanced equation. Loss of electron by the reducing agent, gain of electron by the oxidizing agent always equal. Just do equate it. You will get you can easily solve any stoichiometry problem. Stoichiometry problem fundamental part is nothing but one is known, another is unknown. The known may be given in different unit. It may be given in mode. It may be given in volume and molarity. It may be given in directly gram equivalent, and unknown also you will get. Just try to connect with law of equivalent proportion 1:1, and the reaction you have to know, and reaction you will get in your inorganic part of your syllabus. If time will permit, I will try to express, I will try to give different example in a separate video. How do you solve a simple or complicated stoichiometry problem that generally came or will come in Jee-Advanced within 1 minute or 30 seconds. How we will solve, I will share with you. Please stay with us. Thank you to all.